Okay, sweet. So we're all here. And I'm just going to pretend like the camera's not on, and let's just do it. So, okay. Did anyone figure it out? Like, getting close?
I was hoping you guys would.
Okay.
So you could teach me.
So,
Because I tried and I was like, I don't get this.
so I have it like, at least like the process figured out. It's just,
Trying to figure out what order they go in.
no, the part that screws me up is the possible parent combination orders, which is when you're determining gene order in part B.
Mm-hmm.
Because part A is pretty easy. You're just determining what the allele arrangements is for the heterozygous parent, which is pretty easy. You guys get that part at least?
Yeah, it's just
Yeah.
the two most numerous ones.
Yeah. Just the two most numerous ones. But then just from there, figuring out the gene order, that's where you have to find like the parental offspring, the DCOs, and then somehow from there figure out what the right parent combination is. And that's where I don't know how she gets it.
Yeah, I was just confused on like her. She gave three possibilities.
Yeah.
But I was
And their conditions are always
like two of them have C first, one has the W first. Because like the two that have the C, like the W and the SH are switched, but why not like the W first? Why is that?
Yeah.
Another possibility with like the C and the SH switched, you know?
Yeah. Oh. So yeah, I'm gonna try to find the spot in the video where she talks about that, and I'm just gonna play it and see if one of us can put it together. I don't know. All right, I think this is it.
double crossover offspring. Okay, so we learned clear back in the first week of class that when these chromosomes line up during meiosis, that they can cross over. Okay, so you've got chromosome, and sometimes these little ends especially are going to switch places. Okay, they're going to wrap around each other, get really close, like that. They're going to swap. And what we want to know now is the double crossover events. So that was a one crossover over here, double crossover, look, something like that. Okay, two crossing over events. Your double crossovers are always the least numerous of the F1 progeny classes. Okay, so your parental ones were the most numerous amount of crossing over occurred. And now we're going to go to the most amount of crossing over, and they are the least numerous of all of them. Okay, so if you go back to that data and look and see, what do we have? We have one class that only has 20, and one that only has 15. Those are the least two. Okay, so those are your double crossovers. The double crossovers. Okay. So when we set this up, double crossovers, what's going to happen is there can be a crossover here and then a crossover here between these genes. So what it's basically going to look like is this big WX and little WX are swapping places. Okay. And what will happen then is we can figure out which gene is moving. In respect to the other ones, and we can figure out which the middle gene is. And that's our first step, is to determine which gene is in the middle. So to do that, we need to write the three possible gene orders in heterozygous parent. So we have one gene order written here, but then we need to write down the other possibilities as well. So we could have a WX, CSH, or we could also have a CSH, WX, on the big C, SH, big WX. Okay, these are the
So, like,
three
where did she get
possibilities.
this?
Okay. Yeah.
Because like these two have C first, I will have WX first.
Yeah.
No, SH first.
So I think what she's doing is
Is it because they're the same front and back?
and it is
I don't know.
because it looked. Oh,
Yeah, I think that might be why actually.
What?
Because they're the same mirrored. So like, it's like there's two with C first, and then there's two with SH first going this way, and then there's two.
So you can't do SH on that side because it's kind of just doing the same thing, I guess.
Yeah, because if you did SH, it'd be the same thing. So like if you did SH, CWX, it'd be the same as this one. Does that make sense? I
Mhm.
might be wrong. I don't know.
No, that
But
makes sense.
she said like later on, it doesn't matter like, which way to do.
Okay. So that would make sense. My question is, how did she get? Why is it that the dominant one is on the bottom versus this one? It's flipped. You know. Did you get that?
Why aren't they?
Like,
flipped?
yeah. Why is the dominant one's down here instead of up here?
I think she said it doesn't
Or-
matter.
Okay.
Yeah, I don't think it matters. Like you could like flip the whole thing.
Okay. All right. So
So then how did you figure out that the last one was the one? Is that it?
I don't know.
That you could possibly have out of these different combinations of genes. Okay. So to determine now which one of these is actually the reality to these data set here, to these numbers. Okay. So the one right here that had 20, if you look at it, it says that it is colorless, a little c, waxy, WX, and shrunken. And this 15 right here is colored, non-waxy, and long. So these two phenotypes were inherited then after a double crossover event happened. So we know we got this set, or you got this set when a double crossover happened. So our next step is determine how these could possibly happen from this set of things up here. If a double crossover event occurred here, would it produce one of those? Or if a double crossover event happened in this case, would it produce one of these? Or if a double crossover event happened here, would it produce one of these? That's what we're looking for. It will help us determine which of these three situations is reality. Okay, so I'm running out of room here to write. But in each case, like I said, it's essentially these middle genes are swapping places. So this one, if a double crossover happened, you get a little C, a big WX, and a big SH. And on the bottom, you get a big C, a little WX, and a little SH. So that's not it.
Oh, okay.
You know that that's not the way.
That
You're
makes
looking
sense.
for
Yeah.
all recessives or all dominants. Okay. So
Oh.
here you get a WX and a big C and a big SH. big WX, little c, little sh. So we know that that's not it either.
For a double crossover.
And
Basically,
over here,
you switch the middle one,
the little c, little sh.
create all littles.
Oh, that
All
makes
bits
sense.
to the bottom. Right? Mm-hmm. So these are all bits. So that you're looking for the double crossover genotypes up here. Like, so which one of these crossed over makes these genotypes of
That makes sense.
the lowest.
That makes a lot of sense.
So once you get that, you get all littles. So that's all littles. And then all figs. After you cross over the present. Yeah. Makes sense. So that was the only problem that messed you up, right? Or the only problem.
Yeah, but it's snowball effect. Everything else changes. So,
Little
I guess that goes
WX.
through the process of how you.
yeah. Well, I just want
Or-
to see.
On the bottom, the big C
I just want to double check and make
Big
sure
SH.
that
and a big WX.
I'm not wrong as far as how.
So that sounds right.
Like how you use that.
Right?
from
Good.
there.
Recessive, 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 dominant, dominant, dominant. Recessive, 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 dominant, dominant, dominant. So we know that this one here is giving us our correct gene order. So we know our proper gene order, and we can go ahead and write it down. So C S H W X,
So that's the answer to B.
big C S H
Yeah.
W. You know that this is the order of the genes as they appear on the chromosome. Now you may notice on the answer key that it actually writes it going the opposite direction, WX, SH, C.
Which,
But it does not matter. We're just going gene order here, as long as it's in the correct order. C on one end, SH in the middle, and the WX on the other end, making the sandwich like that. So, and that, my friends, is how you determine the gene order. So by now, we've gone all the way up through step 3. Check. And we'll need another video to carry on after that.
okay. Okay. Yeah, does everyone get that?
Yeah.
Okay.
Like, yeah, I guess I should watch that video. So that would have been very helpful. Because like I got to it, I was like, I have no idea. I was reading it, I was like, I don't understand.
Yeah. Okay. So the next thing you do from there is you rewrite your test cross that you did at like the very beginning, which is so like the first one you did, where it's just like the two parents. You just rewrite it into the order that we just figured out. So it's C S H W X. And the only reason for that is just to help you figure out all of this stuff, and this stuff is kind of a pain from here, but so what from what I got from the PowerPoint. So the next thing you do is you're figuring out like the distances between the genes, which is like the map distance. The formula gives in the PowerPoint is this one right here: is map distance is equal to number of recombinant offspring over total number of offspring. And recombinant just means that it's
Like the
it's not the same as the parent. So from there, it's literally just you do it in the different order of the different genes. So the first two genes in the order we found, C and SH, and you just look for in here. You have to reorder this so it's in the same order as what we found, which is this right here. So you reorder it so it's colorless, and then these, and then those, right?
Mhm.
And then you just find the ones that for C and SH, you find the ones that match the parent, either parent, doesn't matter which. So for example, like first parent is colored and plump, right? And then we're just going cross out all the ones that are colored and plump. So it's the 99, that's 15, those only ones. And then, which is, what is it? It's colorless and shrunken. So yeah, colorless, shrunken, and it should leave only 4 left. 1, 2, 3, 4. Yeah, it leaves 4. And what you do with those is you take those numbers, the 4 that are left, so that one and this guy and that one and this one. And then, so for C, SH, you take those. So again, it's recombinant over total number of offspring times 100. So that's 974 plus 2349 plus 951 plus 2216 over the total, which is 6,708 times 100. And that gives you, should be like some decimal, or times 100, it'll give you like an actual number, and that'll be the answer for that one. And then you just do the exact same thing, except instead of for C and SH, you do for the second two. So it's SH and WX. And you just do the exact same thing. And then all you have to do for like the actual like creating like the map. The reason it's called a map is you're supposed to like draw it out like this down here, just in order of.
And then figure out how far away they are. Right?
Well, that is how far away they are.
Oh.
That number is how far away they are, and like the map is just putting in order of how far away they are. So like closest to farthest away, basically. And just I don't even know why they have you map it out, to be honest. And then
What's the interference value?
So interference is the calculate interference. Okay. So where is it? So interference is the number of observed double crossovers over the number of expected double crossovers. So, okay, and the way you find that, okay, I remember how I did it now. Okay, so you take those two numbers that you find up here. So let's say for those two you find like these are wrong because of all that we figured out, but principle is the same. To say you find the answer is 31.4 MU and 70.8 MU as your two distances. What you do is you take that number but divide by 100, so like 0.314. You multiply that by this one divided by 100, which is 0.708, right? And that gives you your double crossover frequency, which is, in this case, that would be 0.22, or just like 22.2%. So that's your double crossover frequency. You take that and you multiply it by, to find out the expected number of double crossovers.
22% seems high.
I know, yeah, that's because it's because this is wrong because of that, but this is still how you figure it out. So yeah, you take that, you multiply by the total number of offspring to find out how many you're supposed to have. Yeah, so in this case, that would be, even though it's wrong, it would be 1,489 would be the expected number. And then you look at how many you actually have. So in this case, that's 20 plus 15, so it's 35. And then the formula, if it's in the teacher's notes and instructor notes on step 8, it gives you the formula for how to do it. And it's interference is equal to 1 minus C, and C is the observed number of double crossovers over the expected number. So for this, that would be 1 minus the observed, so 35, 20 plus 15, 35 over 1489. And that would give you the interference.
Some like tiny number.
Yeah. So it'd be like, yeah, it's 2.something%. And that's how you'd find it.
Cool.
Yeah. Pretty much, but
To know what to do now.
yeah. Well,
It's gonna take time a little bit.
yeah. Well, once we figure out that stupid crossing over thing. But yeah.
Any other questions?
No,
Yeah.
it made a lot more sense though.
Yeah. I'm probably just gonna chill here and work through them. So, I mean, if you guys are gonna stay, then we can work on it together. But forget, is everyone good though? I'm gonna stop it.